Welcome to Math 1314. This video is on quadratic equations. It would cover sections 3.5, 3.6, and 3.7. So first off, what do quadratic equations look like? Well, let's see. They're typically in the format of something, a number, times x squared, plus a number times the variable. This has an exponent of 2. This has an exponent of 1. And then here on the end, we have another number, and it's equal to 0. The A, the B, and the C are any real number that you like. The only restriction is A can't be 0. If A were allowed to be 0, that term would be gone, and I would lose my variable being squared. So for example, 3x squared minus 2x plus 11. So I'm looking in the front, that's A. B is minus 2, the sign goes with it, and C is 11. X squared minus 9. Well, sitting in the front here is the invisible 1. So A is 1. And what about B? Where was B again? It's the number in front of the X. But I don't have any X, and so B is gone. C is the number on the end, which is minus 9. All right, what about this one? 5x squared minus 25x equals 0. All right, A is 5, B is minus 25, but there's no number on the end, so C is 0. The A, B, and C could be, in this case, there are fractions. It could even be the case that maybe I had 2.5 x squared minus 11.6x plus 13.1 equals 0. So it could be the case that maybe A, B, and C are decimals. Any real number you like, just not allow the first one to be 0. All right, now let's go into the future for just a moment. If we have my quadratic part, but I have f of x in the front, we get something called a quadratic function. And if I graph this quadratic function, it's a U-shaped item that looks up or it looks down. That's all a quadratic function can look like, is a U shape. The lead coefficient tells me if it looks up or it looks down. So positive in the front, it looks up. Negative in the front, it looks down. Well, you might say, well, why do we care about that? Well, the reason we care about that is if I graph the quadratic function f of x is x squared minus 9. It's a U-shaped object. The lowest part is here at negative 9. And if I look, this U-shaped object is crossing the x-axis in 2 places. And those 2 places happen to be the solution to the corresponding quadratic equation. So this equation actually has 2 solutions. Now if I graph another quadratic function, f of x is x squared plus 1. Well, if we look at that graph, it does look up, but it never gets lower than the x-axis. it touches here at 1. So what that means is when I solve the resulting quadratic equation, I'm only going to get one real number answer. And namely, that place is here at 1. And finally, it could happen, for example, here, f of x is x squared plus 16. The U-shaped parabola never gets lower than 16. It never gets down here to touch or cross the x-axis. So when I go to solve the corresponding quadratic equation, I'm not going to find any real number answers. All of the answers that solve this are complex numbers, and they happen to be plus or minus 4i. So, when we go to solve our quadratic equation, which looks like this, we're either going to get two real number answers, one real number answer, or two complex number answers. So how do we solve these things? What is our strategy? Well, we have a couple of different techniques. We could factor this thing as a product of two things, and then we use the fact that if a product is 0, the only way that can happen is if one of them or both parts must equal to 0. So if factoring works, this would be easy to do. Our second way is called the square root property. Now it only works if my problem is in a real special format, and that is I get something squared equals a number. Just this on the left and a number on the right. But if it's in this format, I can conclude I get the inside part back equal to plus or minus the square root of the number. And this fact basically comes from factoring. Our third way is called completing the square. It does work. It's a bit long and torturous. The idea is I want to take my basic equation and I want to turn it into the format for the square root property, because we know how to solve that now. The fourth way is probably the best way that you're going to use most of the time, and it's called the quadratic formula. It's this big formula, but all I have to give it is A in two places, B in two places, and C in one place there. And if I put A, B, and C in there, I calculate this thing and I can get my answers. Now this item that's sitting right here under the square root, it has a name because it does some good things for us. We call it the discriminant. And it's a way to predict what kind of answers we're going to get. This discriminant could calculate to be 0. Well, if it's 0, it's all gone. I don't get a plus or minus because it's gone. And so we would get one real answer. If it calculates to be bigger than 0, well, then the plus or minus comes into effect and I get two real answers. It could calculate to be less than 0, and if I've got the square root of a negative number, I'm going to get a complex number. Hence, we're going to get two complex number answers. All right, so let's take a look here. In question 1, I have a product of two things is 0. It's already factored, so I just set each piece equal to 0 and solve. I can move the plus 8 to the right, giving me a minus 8. I can move the 4 to the right, giving me minus 4. And therefore, this equation has two answers. Geometrically, it's telling me that this quadratic function would be crossing at minus 8 and minus 4. In question 2 here, again, I've got a product of two things equal to 0. And so I can just grab each part and set it equal to 0. I move the 7 across the equals, making it a minus 7. I move the 9 across, making it a positive 9. And then to get rid of the numbers in the front, I divide by 2 and I divide by 4. So this particular parabola is crossing at two places. Now in question 3, I don't have a quadratic because here I've got 3 pieces. So I still have the possibility of this product being equal to 0. So I just grab each piece, including the one in the front there. So x equals 0, that's one answer. X minus 2 is 0. I can move the 2 and I get x equals 2. And on the last piece, let's see, I can move the 1 and then divide by 2. So it turns out x cubed looks like a little snake, and it's crossing here at minus a half, 0, and 2. So 0 is a legitimate answer. Now, this thing in the front, let's talk about it just for a moment. If my problem looked like 3x plus 1, x minus 2 equals 0, you might say, well, you've got 3 pieces again, and you're going to set each piece to 0. Well, no. You see here, that's a variable. It can calculate to be 0. This lead part is always 3. It's never changing. But this part could be 0. And similarly, this part could be 0. So I'm only setting to 0 those pieces that could calculate to be 0. All right, in question 4, we have something that's not factored. Anyone remember what it's called? It's called a trinomial because it has 3 terms. Whenever we've got 3 terms, the first thing I might look for is there any number or variable in common? But there's not here. So it's going to factor as a product of two things where I need to figure out 1, 2, 3, 4 items. Now, this 4p squared in the front, well, it could be 2p times 2p, that's a possibility, or it could be 4p times p. So one of these possibilities is what goes in the front. Now the last number got a minus 5. Well, that could be a 5 and a minus 1, or it could be a minus 5 and a positive 1. So for these four places, I've got all these possibilities. However you pick them, when you calculate the middle and you add the outside, I've got to get that middle piece. So I picked 4p and p, that is the 4p squared. 5 times minus 1, that is the minus 5. The middle gives me a 5p, the outside a minus 4p, and when I combine those, I get 1p, which is the middle piece. All right, so then I just grab each of my parts. So here's part 1, here's part 2. I grab each of my pieces, set it equal to 0, and then solve. All right, let's see. Question 5. Well, question 5, oh no, it's not equal to 0. Oh no, so what do I have to do? Well, I've got to move that 10 over to the left because I need my problem equal to 0. All right, so let's see. Well, for this 12 in the front, I could have 12 and 1, 4 and 3, 6 and 2. This minus 10 on the end could be 5 and 2, 10 and 1, and I've got to adjust who gets the minus. So let's see, I picked the 4a and the 3a. Yep, that is the 12a squared. Minus 5 times 2, that is the minus 10. Let's see if I get this middle term. Well, minus 5 times 3a is a minus 15a. I get an 8a. All right, and if I add that up, yes, I do get the middle piece. And so I simply grab each one of these and set them equal to 0. Here, I move the 5, it becomes plus, then divide by 4. Here, move the plus 2 to the right, it's going to become minus, and then I divide by 3. All right, in question 6, well, when you first see this, you think, wow, it's factored already. But the problem is the thing on the right is not 0. So I'm stuck multiplying this thing out, and then I've got to bring the 4 over. Let's see, t times t, t squared, t times a minus 2t, 1 times t, a plus t, and a minus 2. And I can at least combine these two pieces to give me a minus t, and then I'm going to bring the 4 over. So that's minus 2 minus 4, and I get a minus 6. So I finally do get my trinomial, my thing with 3 terms. And I'm going to try to factor it. Let's see. T and t is t squared. Minus 3 times 2 is the minus 6. The middle is a minus 3t. This is a plus 2t. And yes, I do get the minus 1t in the middle. From there, it's easy. I grab each piece and set that particular piece equal to 0, and then we solve. All right, question 7. Question 7, I see it has 4 terms. 1, 2, 3, 4. And whenever it has 4 terms, I automatically know I've got to group it. All right, now when I'm looking at this, I see there's this problem thing right there in the middle. And if you remember back in section 2.3, when we grouped it, I had to worry if the connection was a minus in the middle. The first two, you could always put parentheses on. That won't change anything. But as soon as I put parentheses around the second part, notice I had to check to change the second sign. From there, I take out whatever is in common. So v squared, a 9. And then I've got more in common, this 2v plus 5, take it out. And when I get to this step, I'm wondering, is it completely factored? Well, this piece reminds me of something called the difference of two squares. Because v times v is v squared and 3 times 3 is 9. So, whenever I've got something like this, it factors into a plus and a minus. And once I remember that, well, I just grab each of these pieces and set them equal to 0. And from there, it's fairly straightforward. All right, question 8 continues this process. So let's see. 4 terms, 1, 2, 3, 4, an ugly minus in the middle. Okay, put parentheses on the first two. There's my minus. I had a plus, and now I've adjusted it to make it into a minus. So from there, I'm going to take out whatever's in common. Well, I can see there's at least a q squared in common. And it turns out that looking at these two numbers, 16 is in common as well. And so, what about this part? Well, not sure, but since I probably want more stuff to come out, you kind of know that the second piece has got to be 5q minus 4. And so, well, what do I need in the front? Well, 9 times 5 is 45, and 9 times this minus 4 to give me the minus 36. So, again, factor this big thing out. I'm wondering, am I done factoring? And the answer is no. Again, I've got something squared minus something squared. And it factors into 4q minus 3, 4q plus 3. And so from there, like always, we grab each piece, set them equal to 0, and solve. Okay. Now, that finishes the factoring part. Let's look at this thing called the square root property. So again, it says, if my problem looks like something squared equals a number, it's got to look just like this, then I can conclude what? What can I conclude? I can conclude I get the something back, no squaring, I get a plus or minus, and I get the square root of whatever number was there. All right, let's take a look. So, in question 9 here, I've got 9t squared equals 196. Now, right now, the only thing squared is the t. I don't have the whole side squared. Now, some of you might say, well, couldn't you make that as something square? Yep, I could. I could write this as 3t squared, and that would work too. Okay, so it is possible. That would be fine. I would get something squared equals a number. But in this case, I just chose to divide by 9. And then by the square root property, when I get something squared equals a number, my next step is I get the item back plus or minus the square root of the number. I can split the square root when I have a fraction, and this is square root of 196 over the square root of 9. Square root of 196 is 14, and the square root of 9 is 3. Okay. Now, would I have gotten the same thing the other way? Yes. If I did it this way, I would get 3t equals plus or minus the square root of 196, and that would give me 3t is plus or minus 14. And if I divide by 3, I would get t is plus or minus 14/3. So whatever you see, it's going to work out the same way. All right, question 10, let's see. So I probably should clean this up first. So I'm going to divide both sides by -3. 27 over -3 is a -9. And so I do have something squared equals a number. Now notice I don't need the number to be positive or anything special, any number. And so by the square root property, I get m is plus or minus the square root of -9, but the square root of -9 is square root of 9 times -1, which is square root 9 times square root -1. And the square root of 9 is 3. And we've agreed to call this item, square root of -1, I. All right, what about question 11? All right, looking here at 11. I've got something squared equals to a number. Okay. So, got that there. I can conclude by the square root property. I get this thing back. I pick up a plus or minus and then the square root of the number. Now, if I move the -2 to the right, I'm done. So 2 plus or minus the square root of -45. But usually we want this in the simplest form, which means I need to simplify this. Well, let's see. This is square root of -45, which is square root -9 times 5. Square root of -9 is 3i, but square root of 5 I don't know. And so my final answer then is 2 plus or minus 3i square root 5. Now some of you may wonder, do you have to write it that way? No. I could write it 3 square root 5 I, which is okay. It's just you got to be careful that the I doesn't seem like it's underneath the radical, because it's not. It's outside by itself. So you could write it that way. Nothing is wrong. It's just you typically write it this way so there's no confusion as to what's under the radical. All right, this technique called completing the square. Whole idea is to take my quadratic equation and turn it into the square root property. Because if we can do that, we know how to solve it. How does the process work? Well, first thing I look at is the lead coefficient of 1. If it is a 1, there's nothing I need to do. If it's not a 1, then I need to divide everything in the problem by a, because the technique needs a 1 for the lead coefficient. Next, I move the C number to the right-hand side. You say, what is this C? Well, remember, C was the number stuck on the end, so I'm moving it to the right. Step 3 is where all of the important work is done. So let's put a star by that. First thing I do is I look and I answer, what is B? Okay, and here B is minus 4. I then need to make two calculations. B divided by 2, or if it happens to be easier, 1/2 times B. And whatever that gives me, I'm going to save it for factoring. So in my example, B was minus 4 over 2 is minus 2. Once I get that number, I'm going to put it over here, my B over 2, and square it. And I'm going to save that. So you see, my B over 2 was minus 2. I'm going to square it, and I get 4. Okay? Now you might say, what do you mean B over 2 or 1/2 times B? Typically, the first one is the easiest. But if B happens to be a fraction, then 1/2 times B is not as confusing. All right, once we've got that, what do we do next? We take the B over 2 squared, and I'm going to add that to both sides. So let's see, here's where I was before. My B over 2 squared was 4, and now I'm adding it into both sides. Leave the left side alone and simply combine the right. Now, once you've added this thing in, the left-hand side will always, guaranteed, factor as whatever your variable is, and the factoring number I saved squared. Let's go back up here. Remember, my factor number was this B over 2, and look, it's minus 2. So look, I just fill it in. So that thing squared equals 3. But now it's easy. It's exactly the square root property. And so I get x minus 2 equals plus or minus the square root of 3. And move the 2, and we are done. All right, in question 12, they don't want us to do any solving. They just want us to figure out, well, what would this n have to be to turn it into a perfect square? Well, all I have to do is grab b. b is minus 6 divided by 2. That gives me minus 3, and that's my factoring number. I take that number and I square it, and I get 9. And I need to add that in. So that's the amount I need to add in to make it true, because now it factors as y minus 3 squared. All right, in question 13, the same. I need n, so I grab b. b is 1. b over 2 is a half. That's my factoring number. I grab my half and I square it. 1/2 squared is 1/4. And that's the amount I need to add in. And this thing would factor as y plus 1/2 squared. And that's the beauty of this. I don't have to wonder how this thing factors. I'm guaranteed it will always factor as your variable, your factoring number squared. All right, question 14. They want us to do all of it. So let's see. So first off, let's see. I'm looking, is A equal 1? Yep, the lead part is a 1. So I move the C out of the way. Okay, so if I move it out of the way, I get W squared plus 6W equals minus 8. All right, so then I grab B. Here's B. B over 2 is 3. That's my factor number. Grab that number and square it, and I get 9. All right, so that's the part I'm going to add in. So here's where we were. I now add 9 to both sides. 9 minus 8 is 1. This part is guaranteed to factor as variable. My factoring number, which is a plus 3 squared, equals 1. But then it's easy. I just use the square root property. I move the plus 3 to the right. Okay, moving that this way. And now I take advantage of the plus and the minus, and I get minus 2 and minus 4. All right, what about question 15 here? Let's see. All right, so lead coefficient is a 1. There's a 1 right there. That's good. Check. I move the number out of the way. Got it. I'm looking for B. B is a plus 8. 8 divided by 2 is 4. That's my factoring number. Square it and I get 16. And so here it is. I'm adding 16 to both sides. 16 minus 21 is a minus 5. And the left, I know how it factors because there's my factoring number. Something squared equals a number. Okay, great. So I get it back, plus or minus square root of the number. Move the 4, and this square root of minus 5 is, I can at least pull out a I. All right, question 16. Hopefully you're having a good time so far. All right, 16, we have a application. We have a shelf that's going to go in the corner here. Looks like it's a right triangular shelf. This is X, this is X. All right, and they want me to figure out, well, how long is X if I want this piece to be 4 feet? Well, we need something called the Pythagorean theorem for right triangles, and that is the sum of the squares of the two sides must equal to the hypotenuse squared. All right, so that says in our case, x squared plus x squared is 4 squared. Okay, that's easy enough. Well, but 1x squared plus 1x squared is 2x squared. And if I clean that up and divide by 2, I get x squared equals 8. All right, so I'm done. X is plus or minus the square root of 8, but I need to simplify that. So 8 is 4 times 2. And so square root of 4 is 2. Now, mathematically, we're done. But in this case, x is a length. Making a minus makes no sense. And so I only keep the positive number. Now, please don't think I'm saying you always keep the positive number, because in some physics applications, for example, supposing I have here's a wall or a ceiling, and I put a spring here, and I'm hanging a weight from it. I'll put W for weight. Now, wherever this thing stops hanging, we call 0. And if I stretch this, well, what's going to happen? When I let go, it's going to go boing and go up and down and keep going up or down. Well, in that case, I've got to assign a direction. How do I call down? Well, maybe down farther is plus. And if this thing goes boing and goes back up more to compress the spring, I get a minus. So sometimes in a physical problem, you have to determine, is the plus important or is the minus important? In our case, it was a measurement of length, and it was the measurement on a wall, and so as a decimal, we got 2.8 feet. All right, our final way is called the quadratic formula. All right, so the quadratic formula needs A, B, and C. And I just plug it into all the places. Now, there's a couple of dangerous places right here. B could be negative. A negative times a negative would make this lead thing a positive. Most people catch that though. Here, it's your b squared, so that should always be positive once it's squared. What most people miss is this part. I put it in parentheses because it could calculate to be negative, and I would have minus a minus. So just be careful in the front and definitely here under the radical. Let's see, question 17 here. All right, let's see. I've got A, lead part is a 1, B is 3, C is a minus 28. The sign goes with it. All right, so let's see. Here's B in its places. A is 1, there's A, and here's my minus 28. Let's see, minus 1 times 3, minus 3. 3 squared is 9. What about this stuff? 4 times a minus 28 is a minus 112. But I've got minus a minus 112, and look, it's a plus. That can matter a lot, from changing your answer to be positive, which I'd have a real square root, or if it's minus, I would have a complex number. But here it's a plus. I get the square root of 121. But that's a nice square root. That's just 11. And so my answers are minus 3 plus or minus 11 over 2. If I use the plus, it's minus 3 plus 11, which is 8. 8 over 2 is 4. Minus 3 minus 11 is 2. Minus 14 over 2 is minus 7. So there are my two answers. And if you remember geometrically, it's telling me where my U-shaped object is crossing on the axis. All right, question 18. Okay, question 18. Well, let's see. I got a minus 5p squared minus 14p plus 3 equals 0. Now, if you just hate the minus in the front, you could multiply all the way through by minus 1 and make it positive, and you'll still get exactly the same answers. I'm going to leave it there. Let's see. A is minus 5, B is minus 14, C is 3. Let's see, A, here's A. A is in two places down there, and here's A. Okay, got A. B, B was in here and in there. And C is stuck here on the end, my 4AC. Okay, that looks good. Negative 1 times negative 14 is a 14. 14 squared is 196. Oh, this calculates to be negative, and minus a minus is a plus 60. So if I add these up, I get the square root of 256. Okay, that's a nice one. Square root of 256 on your calculator is 16. And so again, I'm going to use the plus and I'm going to use the minus. All right, so you can see I just grind through that, giving me two answers. All right, in question 19, we see the case where the quadratic equation could have decimals. Typically in real life problems, A, B, and C will always be decimals. Very rarely are they nice numbers. But the important thing to realize here in this problem is it's not equal to 0. I need to move all of this junk to the left to make it equal to 0. Once I do that, I can get A, B, and C. And I plug in A, there's A, there's A, here's B in there, and there's my C stuck on the end. Let's see, minus 1 times minus 2 is a positive 2. Minus 2 squared is 4. Turns out all of that stuff is 4. That's great. It goes away. 4 minus 4 is 0. And so I simply get one answer, 2 over the 0.8. And if you calculate that, you get 2.5. All right, question 20. We're going to calculate the discriminant. You say, what is this discriminant thing? Well, way back on the quadratic formula, remember it looked like minus 1 times b plus or minus the square root of something all over 2a. This thing that's under there, we call it the discriminant. And it is b squared minus 4ac. And if it calculates to be 0, I get one real answer. If it calculates to be less than 0, we get two complex number answers. And if it's bigger than 0, we get two real answers. So in question 20, I'm not trying to find the answers. I'm just trying to figure out what kind I would get. So all I do is find A, B, and C again, plug it into this thing, grind away, and in this case, I get minus 71. Well, if the discriminant calculates to be a negative number, my conclusion is I'm going to get two complex number answers. All right, and the last one here, let's see. Again, looking for the discriminant. Now again, be careful, don't just run in. Looking at this thing, it's not equal to 0. So you really can't read off A, B, and C. So I'm going to move this 6, and I get a 0. And I see A is minus 2, B is 5, and C is minus 6. So plug all this stuff in. Be cautious about this piece. So here's my b squared minus, and then I got all this stuff in parentheses. And so, well, a negative times negative is a positive, so this turns out to be 48. When I calculate my discriminant, I get minus 23. Well, that number does calculate to be less than 0, which tells me if I solve it, I'm going to get two complex number answers. All right, well, this is a pretty long video today, but it completely talks about how do we solve quadratic equations, which tells me where the function possibly crosses on the x-axis.